Good morning everyone. So we'll solve this numerical today, which has got a UDL and also a point load. And what is the first step that you will actually do? So you first convert this into a free body diagram. So what is a free body diagram? So free body diagram only consists of only forces acting on it, no supports are shown. No supports are shown. So you try to replace this with arrow marks. These arrow marks are actually basically force vectors. These actually force. So free body diagram only contains force vectors, nothing else. No supports, no hinges, nothing. Okay. So you are replacing that hinge with a vertical force because it is a simply supported beam. It only supports, nothing else. And also you try to name this as A, B, C, D. It's left to you how you do it. Okay. So and each of these are actually at a 2 meter distance. So this point load is at a 2 meter distance from here, and this UDL is for a distance of 2 meters, and this again is at 2 meters. So, and I said, should you do the calculation here? No. Now what you should do? You should draw, you should draw these lines so that you can reserve this place for SFD, BMD. You draw this. Okay, and then you can start doing the calculations maybe in the next page. So suppose if given in the examination, suppose if it is a booklet, the left hand side of the booklet you start with this numerical, and the right hand side of the booklet you start with the calculations. Okay, you always start these numericals right from a fresh page on the left hand side, so that you have enough space to see the calculation and also write these values here. Otherwise, there will be a lot of circus in trying to turn in the pages, and it takes a lot of time for you. Okay, so you are now replacing this. Now, can you suggest? So can you tell me what is that I should write first now? Huh? Here. To find out the reaction forces, what I should write? Huh? Reaction at D. So can I find the reaction at D directly? I should actually use two equilibrium equations. What is the first equilibrium equation? Summation of moments is equal to 0. So summation of moments is equal to 0 about A. So I can take any of the points. So I can take any of the points here is 0. Summation of the moments about A is equal to 0. So that means all the moments about A. So that means the clockwise moments and the anti-clockwise moments are 0. So let us take the clockwise moments as positive. Okay. So clockwise as positive. So here 2 kilonewton acting at a distance of 2 meters from this A end is positive. And then what about this? Is it plus or minus? UDL is plus or minus? Is this UDL plus or minus? It is plus. Okay, so this whole UDL can be assumed to be taken at the center of the UDL. Center is at how much distance from A? It is at 3 meter distance. So this total UDL for every meter it is 2 meters. Sorry, 2 kilonewton. For 2 meters it is actually 2 kilonewton for every meter multiplied by 2 meters. So meter cancels out. It is only left with 2 kilonewton. Acting at a distance of how much? 2 plus. So 2 plus 1, 3 meters. So 2 plus 1, 3 meters. Okay. Okay, is it visible in the video? Okay, is it visible up to here? Okay. So then you got only one force which is actually positive, which is that plus, okay, is this positive, negative? Positive. It's positive. So only one negative force here. So minus RD. Minus RD into what distance? RD is acting at what distance from A? 6 meters. So 6 meters is equal to 0. So now, what is this value here? So that is plus 4 kilonewton meter. So what is this value? 2 into 2, 4. 4 into 3, 12. And minus 6 RD. So RD is equal to, so you can actually bring the 6 meters down here. So basically it is RD into 6 meters. Now the 6 meters comes here. Okay. So you're taking this onto the right side. So here, how much is the value here? 16. I think I made a mistake at that time. This is right, 2 kilonewton into 2, 4 into 3. Okay. So this is 16 kilonewton meter divided by 6 meters. So meter gets getting cancelled out. What is the answer?
2.66.
So 2.66. Sorry, I think I actually made a mistake in that initial calculation. So I got this odd numbers. Okay. So it's an odd number I'm getting. Okay. So usually examiners should take care that you get a whole number. Otherwise it looks odd and the calculations unnecessarily becomes clumsy. So we are actually here to test you how you know SFD, BMD. No, not to really worry about this decimal points. Okay. So 2.66. So once you know this, can you know? So right now what you are knowing is RD value. RD value. So can you know the value of RA? So what equation do you use? Here you use sigma MA is equal to 0. Summation of moments about A is equal to 0. Now what will you use? So that is, you call this as summation of forces. So that means forces going downwards is equal to forces going upwards. So forces going downwards are, so at the right, forces going upwards basically. Forces going upwards is equal to forces going downwards. Forces going upwards are RA plus RD. And forces going downwards are 2 kilonewton. Sorry, is it plus or, sorry, a plus. So 2 kilonewton into 2 meters. So that means this UDL is spread over 2 meters. So for every meter it is 2. So 2 kilonewton meter plus 2. So meter gets cancelled out. It's 4 kilonewton. So it is 6 kilonewton. 6 kilonewton. So you know the value of RD. You know the value of RD. What is the value of RA now? 6 minus 2.66. How much is it? It is 3.44.
3.3.
So it is 3.33, sorry. So 3.34. So 3.34 kilonewtons. So here you replaced it with the whole numbers here. RA is equal to 3.34. Guys, you can literally understand that since this load is more onto the left hand side, the reaction is more. Here onto the right side, the load is less, so RD value is definitely less, 2.66. So if you want to confirm this answer before you go ahead, for confirmation, is this visible in the? So for confirmation, you can actually do sigma MD is equal to 0. Summation of moments about D is equal to 0. Now we should get the same answer. Because the first step is wrong, you may lose full 10 marks. Okay? So sigma MD is equal to 0. So then, once you have done this, so then you set a platform to solve the problem because you replaced all this with just forces. So SFD BMD can be simply drawn by using the definition that shear force at any section is the sum of the forces either on the left side or right side. So here the convention is that if it is the beam, if it is the section that you considered, anything on the left hand side, right hand side going downwards is positive. Anything on the left hand side going upwards is positive. So any section that you considered. So as per this, if you imagine that the beam continues here, that there are no forces downwards or upwards, it is 0. It is 0, it is 0, 0, 0, 0 until it reaches this point. Until it reaches this point also it is 0 because there are no forces here. So I write it as 0 kilonewton. Then as I actually go further here, I see one force of going upwards. A force going upwards on the right hand side. Is it positive or negative? It's negative. So it goes from 0 to minus 2.66. So 2.66. And as you go further here, you only see this force going upwards, which is the same value, 2.66, 2.66. So it remains the same until it crosses one more load here. Okay, it's not a point load, it is a UDL. It is a UDL. So UDL means small loads at every point. So that means, so these loads are positive because it's going downwards. So definitely it will start increasing like this. But how much? We can know only when we reach here. So now as I move the section here, definitely there will be more and more UDL acting, which may bring this forces upwards. So much? So I have to calculate here. So if I calculate here, so 2 kilonewton for every meter for over 2 meters. So much is it? 4. 4 kilonewton minus how much? 2.66. So much is the value. 4 minus 2.6 is 1.334. So 1.34. So it goes to 1.34 here. So 1.34 kilonewtons. You know here 2.66 you mark this much. So 1.34 should be almost half of this. So half of this. Now you should draw a line connecting these two like this here, because the variation is linear with respect to distance. More and more distance you travel, more and more load UDL gets added. So there's linear relationship with respect to distance. So it gets added. Okay. And then as you now move here, suddenly there will be one more jump. One more jump because of this 2 kilonewton. So your period is 1.34 plus 2. So much it becomes?
3.3.
So 3.34. So it jumps to 3.34 here. So 3.34, and you will know that value will be equal to this if you come here. Okay. Now as you go further here, it is now the same thing. There are no forces added here, so it remains the same. It remains the same. And as you cross this point here, 3.34, so there is, okay, it was actually 3.34 plus, and this force going upwards, what happens? A force going upwards on the right hand side, it is negative. So this is plus 3.34, this is minus 3.34 going upwards, so it becomes 0. Okay, so this is how you draw the shear force diagram. Shear force diagram, you understand that as engineers, so they are worried about this section, which has got highest shear force, which is 3.34, and also we have seen that the shear force crosses this 0 line at some point. At that point, you will have the maximum bending moment. Okay, so here, okay, we have to find out the bending moment at all these points A, B, C, D, plus again this point. So this problem becomes slightly longer. So whenever there is a UDL, so this shear force may cross this line at somewhere in between the points like A, B, C, D. So therefore, it actually increases the time of the problem solving time of the problem by actually 5 to 10 minutes. Okay. And now, once you have done this, then we'll go for the bending moment diagram. Bending moment diagram, should I draw this line, 0 line here, like this? Should I draw the 0 line like this? 0 line for bending moment diagram. SFD, BMD. Is it right? Yes. Somebody can say why I should not draw? Because this is actually sagging. Because of this loads, this beam will sag. When this beam sags, here you will have the positive bending moment. So you can't draw the positive bending moment shown here if you draw the 0 line here. So when you draw the 0 line, you see here throughout it is sagging. So therefore this diagram will come above the 0 line here. So draw this 0 line slightly below so that you can accommodate the variation of bending moment above the 0 line, because the bending moment throughout is sagging, which is positive. Okay. Now, again I start with the same convention which I used. Is it visible in the? Okay. Now again in this, I see that for the bending moment, for any section that I considered, right side upwards or left side upwards, both are positive. Okay. If it is ulta, it is negative. So here I start with this point here. Okay, I want to again repeat. Shear force I said, no? Shear force is said 1.34 plus 2, it becomes 3.34. So I forgot to tell you that you don't have to do all these calculations, you just have to see on the left hand side here. Suppose now if you feel this calculation is very lengthy, you just, instead of seeing on the right hand side, see on the left hand side here. So see on the left hand side, the value is how much? So 3.34. So from 0, here if you consider the beam here if you consider the beam, there are no forces, it starts with 0. And as you move here, you will see one force going upwards. Any force going upwards on the left hand side is positive. So it goes from 0 to 3.34. now that 3.34 continues until it meets one more force which is going downwards. So anything going downwards on the left hand side is negative. So 3.34 minus 2, it becomes 1.34 like this. So you can either see right side or left side. You can solve the problem. Okay. So please practice. Otherwise, everything evaporates in your head in few hours or few minutes. Okay. Now here bending moment diagram. I am again starting from the right side because we used to do that. So here, okay, are there any forces here? No forces, no moments. What is actually basically bending moment? Bending moment is actually force into distance. First of all, there are no forces only, so there can be no bending moments. Even now there are no forces, no bending moments. Okay, here now there are no forces on the right side, but here there is one force. But that force is there, but the distance is almost negligible, which is equal to 0. So therefore, at this point, you will have force but 0 distance. So 0 distance into force, it becomes 0 kilonewton meter. Okay. And now, I will erase this so that the calculations are clear to you. So usually for SFD BMD, since it is addition and subtraction, we don't need any calculation because we see the value here, we just have to add or deduct. Okay, you don't have to write this. Okay, I feel so. But okay, in the books they would have explained you to make you understand. But now here, you don't need to show that in the calculations. But maybe for the bending moment. So bending moment diagram, BMD, bending moment diagram. So bending moment diagram at D is equal to 0. Bending moment diagram at, what is this point? C. So what is the bending moment at C? There is one force going upwards. What is the distance? So 2 meters. So going upwards on the right hand side is positive or negative? Both going upwards is positive in the case of, okay. So going upwards is positive, force into distance. So 2.66 kilonewton into distance of 2 meters. So the answer is 5.32 kilonewton meter. So 5.32 kilonewton meter is the bending moment at C. And if you go to this point here, then it becomes very lengthy. So what is the best thing? Instead of seeing on the right hand side, you see on the left hand side. At this point, bending moment at B. Bending moment at B. Don't see on the right hand side, see on the left hand side here. Okay, on the left hand side, what is this value? RE value? So 3.34. What is the distance? 2. So here, bending moment, is it positive or negative? It's positive, 3.34 into 2. So bending moment 3.34 kilonewton into 2 meters. So much is the answer? 6.68 kilonewton meter. So here, you got these values here. So one is actually plus, this is also plus, this is also plus, both are plus. One is 5.32. One is 5.32, other is 6.68. 6.68. And okay, I have to tell you that wherever you got a horizontal line here, you will see an inclined line here. In the case of this BMD. So BMD is 1 degree higher. And then wherever you got inclined line here, you'll have a parabolic line here. You'll have a parabolic line here, something like this. Wherever you got a horizontal line here, you'll got a inclined line here. Basically, it is actually saying like wherever shear force is 0, I mean shear force variation is constant, you will have a constant bending moment which is varying like this. Sorry, constantly varying bending moment. Wherever this shear force itself is varying, bending moment will vary next degree, so that will become like parabolic. Okay, so horizontal, inclined, parabolic, hyperbolic. So parabolic is x square. So this is x to the power of 1. This is x to the power of 0. This is x to the power of cube. Okay. So SFD to BMD, it will always go 1 degree higher. If SFD is horizontal here, BMD will be an inclined line. If SFD itself is an inclined line, BMD bending moment will be parabolic, because it will be varying with respect to distance as well as the UDL will increase, it will be parabolic. Now, I have only said that if it is inclined, it will be parabolic here, it will be parabolic, but I know that it is going to be maximum at this point. But how much is the value? So, if you have solved the problem, suppose if it is actually a 12 marks problem, you may get 2 marks for finding out this values of RE and RD. You may get maybe like 4 marks for this, 4 marks for this, without doing this. So the last 2 marks will be for the location of this point. Okay, the last 2 marks will be for the location of this maximum bending moment point, or some people may consider it given for higher marks. So how do you locate this? So first, if you want to locate, if you want to know the bending moment, if you want to calculate the bending moment at that point, you should know where is this point here. So that point is here. So maybe you can actually use ratios and proportions. Now I will actually try to convert this as a triangle. I'll try to convert this as a triangle. Now you see this triangle. What is the base of the triangle?
2 meters.
So 2 meters. I want to know what is this x. Okay, I want to know x. X is the distance here. What is the height of the triangle? The total height of the triangle. 1.34 plus how much?
2.6.
2.66. So what is it? Now what is the total height? What is the total height? 2.66. 4. So 4 is the total height. Don't worry about what is the unit. 4 is the total height. And what is this height basically? 1.34 is this height. So basically you are trying to have a triangle something like this. So below it is 2 meters. So here it is like 1.34. So the total height is 4. And you want to know what is this x. So you can have ratios and proportions here. 1/34 divided by x and 4 meters divided by 2. So it is in the ratio of 2. So that means that this numerator or this denominator is divided by this. So x will be how much? How much? So cross multiply this x value.
0.
So that is 2 into 1.34. So cross multiply. So what is the value? 0.67 meters. So you get this as 0.67 meters. So x is the value, 0.67 meters is the value of x. Now once you have got this, I should go to that point, 0.67 meters. If I hold this point here, even if I take right side seems to be easier because there is only one UDL and one point load. I'll try to find out the bending moment about this point. So I'll erase this because I need space. So bending moment at x is equal to how much? 0.67 meters. So bending moment at x is equal to 0.67 meters. I'm here. Please help me. Okay, how I should calculate the bending moment here? And what are the forces onto the right side? First force 2.66 kilonewton into what is the distance?
2
So 2 plus this value. What is this value? So 2 plus. So that is, this is 1.61. What will be the remaining? 1.33. Okay. So it will be 1.33. So this is 1.33 meters. Okay. And then what about this UDL? UDL is going downwards. What is the total UDL? 2 kilonewton for every meter. But what is this length? 1.33. So this is 2 kilonewton for every meter. It is spread over 1.33 meters. So that load is acting at exactly at the center of the UDL considered. So center of UDL will be how much distance? 1.33 divided by 2. Guys, most of the people will suffer. Up to this point, their brain works. After this point, their brain freezes. Okay. In that case, you are not fit for good jobs, high-paying jobs. Please. It's not that very complex, but still some people feel it difficult to calculate UDL. So this is 1.33 divided by 2. Okay. So can I calculate the answer now? Bending moment at x. So how much is the answer? It should be definitely more than how much? It should be definitely more than 6.68. Because 6.68 was here, 5.32 was here. So since what is a parabola, it should be like this. Guys, you're not keeping the calculator on the table and using it. You'll struggle. Like grandmas trying to use a smartphone, no? The same way you'll struggle in the examination. Same way you will struggle to use a calculator. Huh? 7.08. So 7.08. Suppose if the answer was like 4 or 3, would you accept it? No, because now the pattern was like this. If it is a parabola, you expect this to go up. Okay? And here, so this is how much? 7.08 kilonewton meter. So this is 5.32 kilonewton meter. Sorry, I did not write this kilonewton meter. 6.68 kilonewton meter. Okay. So that means with this pattern of loading, the beam will have the highest bending moment at this point. So this is the maximum bending moment. So this is the place where it can break due to bending. So it is experiencing the maximum bending moment. So therefore, if it is a beam, you should strengthen here. Should strengthen with extra attachments here, maybe at the top or bottom. Usually at the bottom. Because now it sags, no? If you want to prevent sagging, suppose if I attach a tape here, if I want to do like this, so can I do this? I can't do that because that tape doesn't want to expand. If you put something at the top, now the tape will easily get crumpled. So usually when you have sheets, the sheets may actually get crumpled here, but when you attach sheet below, the sheet wants to expand, or if you put a rivet like this, rivets or welded joints or bolted joints here, so then it will be difficult for it to sag. If you got a tape at the bottom, if you want to bend your hand like this, it will be difficult. If you got a tape at the top, will it make any difference? Of course, you will feel some resistance, but it will not be that difficult because the tape will start bending. But to stretch a tape, paste it at the bottom, it will be difficult because you can't stretch a tape. Are you feeling this? Okay, like this, you may have to do something as an engineer. So SFD BMD is not simply for engineering students to solve and get some marks. It has a lot of implications. So at this point where you got highest bending moment, the engineers may need to do something to make it more strong, because you don't have to make this whole beam strong, because it will increase the what? Weight as well as cost. So wherever there is chance of bending and failure, there you need to strengthen it. Okay? So as an engineer, you need to worry about the points where it will fail. Where it is going to fail, there you need to make changes. So you can make changes here. Okay? Some sort of changes. So that's at this point. So once you have done this, maybe then you can actually and also you will see that bending moment is nothing but the integration of the shear force. So what is this value 6.68 here? 6.68 is actually the total area of this shear force here. So shear force height was 3.34. So height is 3.34. Length is how much? 2. So 2 into 3.34 is 6.68. Okay. So bending moment is the summation of the total summation of the shear forces. As you actually go from here to here, the shear force summation starts increasing and the bending moment starts becoming 6.68. And as you come here, you see that there is a sudden drop and this starts decreasing. Sorry, here it starts again increasing up to this point, okay? Because this area is getting added again. So it will have a small increment, and again from this point it starts going negative. From positive it will start going negative. So from this point it starts again decreasing. It is the reason where shear force crosses zero line, it will start going from positive to negative. So therefore it will reach a maximum point here, then it again starts decreasing. Okay, don't worry, decrease or increase. So basically decrease means the values that got added here. Okay, it will not go back below zero. Okay, it will start doing this. So you don't have to do all this, it's only a check if you want. So if you now integrate the area, suppose if you add the area, you'll get this. Even if you want to see this side, so it is 2.26 multiplied by 2, you get it as 5.32. Okay, something like this.